We're back for the second part of this lesson, and it starts out with an AP exam tip. The formula for the two-sample test statistic for a test about mu1 minus mu2 often leads to calculation errors by students. Also, the p-value from technology is smaller and more accurate than the one obtained using the conservative method. This is the difference between us running the test in Stat.Test and that T-test versus using the values in our table. So as a result, your teacher may recommend using the calculator's two-sample t-test feature to perform calculations. Be sure to name the procedure two-sample t-interval for mu1 minus mu2 or two-sample t-test for mu1 minus mu2 in the plan step. And if you're running a test, report the standardized test statistic, the value of t in your do part, along with the p-value and the degrees of freedom that your calculator reported back to you. Okay, so software offers a choice of two t procedures. One is labeled unequal variances, the other is equal variance. The unequal variance procedures use our formula for the two-sample t interval and test. The interval and test are valid whether or not the population variances are equal. The equal variance procedures assume that the two population distributions have the same variance. This procedure combines the statistical term is pools the two sample variances to estimate the common population variance. The resulting statistic is called the pooled two-sample test statistic, t-statistic. And this is what we did when we did a difference in proportion test. Our advice, never use the pooled t procedures if you have technology that will carry out option one. So if we're going to use our calculators, we're not going to do pooling. We're just overall not going to do pooling with means. Okay, so now let's look about what happens when we're looking at it from a perspective of that matched pair design type experiment. And so we're looking at a mu sub difference. So our null hypothesis would be mu sub difference is equal to the hypothesized value, which is often 0. And our conditions are similar, but now remember, we're not looking at two separate groups or populations and comparing them. What we're doing is we usually have that before and after type scenario. So paired data come from a random sample from the population of interest or from a randomized experiment. That's for a random condition. For 10%, if we're sampling without replacement, then we need to check that the sample size is no larger than 10% of the population size. And for the normal condition, the population distribution of differences or the true distribution is from an approximately normal population, or the sample size is large enough for the central limit theorem to apply, or we have to graph the difference between the two groups. Now, you would never have a different number in one group and the other group when it's a matched pair or when it's a paired t-test. That cannot happen. That would happen with two separate groups of population, two different populations that you're drawing from, but not with a paired difference. So suppose the conditions are met to test the hypothesis, which is mu sub difference is equal to 0. We compute the standardized test statistic. We have some examples of that in our notes. And we're going to find the p-value by calculating the probability of getting a test statistic, a t-statistic this large or larger in either the negative direction, the positive direction, or in both directions if it's a two-sided test in our alternative hypothesis. And we would use the t-distribution in table B with n minus 1 degrees of freedom. So this is an experiment that took place. Researchers designed an experiment to study the effects of caffeine withdrawal. They recruited 11 volunteers who were diagnosed as being caffeine dependent to serve as subjects. Each subject was not allowed to drink their regular caffeine drink, and for 2 days they took capsules with their normal caffeine intake, and during another 2-day period they took placebo capsules which did not have any caffeine. They randomized the order in which each subject had the treatment, and at the end of 2 days they did depression tests to all 11 subjects. Researchers wanted to know whether being deprived of caffeine would lead to an increase in depression. And the table displays data on the subjects' depression test scores. Higher scores show more symptoms of depression. So we have the caffeine group and the placebo. They're the same ones, they're the same people. 11 subjects had both treatments. So do the data provide convincing evidence? We know we're doing a state plan do conclude and running a hypothesis test that caffeine withdrawal increases depression score. So we've got the direction in our alternative hypothesis. So our state, we state the two hypotheses. We have in the null hypothesis, mu sub difference is equal to 0. In the alternative, it's greater than 0, where the mu sub difference is equal to the true mean difference, placebo minus caffeine, in the depression test score for a subject like these. Now, we could have done it either way. We could have done caffeine minus placebo or placebo minus caffeine, depending on whether we want to end up with positive results or negative results. They didn't tell us what significance level to use, so we're going to use 0.05. We're going to, in the plan, state what type of inference we're going to use. And this is a paired t-test for mu sub difference. In random condition, researchers randomly assign the treatments to the subjects and the order of the treatments, because they both had both treatments. And then the 10% condition does not apply. On the normal or large sample condition, we graph on a histogram. We don't see any strong skew or outliers, even though the sample size is very small. So it's hard to say for sure, but they were reasonably uniformly distributed. Okay, in our do, again, we have some messed up font here, but anyhow, the degrees of freedom that we used was 10. We came up with a test statistic of 3.53, and we can either use table B or use technology to come up with the p-value. Whichever way you slice it, we've got a very small p-value. So we're able to say, because the p-value is smaller than the alpha, we reject the null hypothesis. We have convincing evidence that caffeine withdrawal increases depression test score on average for subjects like the ones in the experiment. So how do we know whether we're doing paired data or a two-sample t-test? And two-sample t-procedures require data that come from independent random samples from the two populations of interest or from two groups in a randomized experiment. The mu sub difference, or the paired data, paired t-procedures require paired data that comes from a random sample from the population of interest or from a randomized experiment. Again, typically what we see is a before-after kind of situation, or somebody is their own control group and they get both treatments. Caution, the proper inference method depends on how the data were produced. So this is where we have to read the question very carefully to make sure that we are understanding exactly what's going on so that we can put it in our plan. Okay, new problem. In each of the following settings, decide whether you should use a two-sample t-procedures to perform inference about a difference in means, or paired t-procedures to perform inference about a mean difference, and explain your choice. So for question A, before exiting the water, scuba divers remove their fins. A maker of scuba equipment advertises a new style of fins that is supposed to be faster to remove. A consumer advocacy group suspects that the time to remove the new fins may be no different than the time required to remove the old fins on average. 20 experienced scuba divers are recruited to test the new fins. Each diver flips a coin to determine if they wear the new fin on the left foot and the old fin on the right foot, or vice versa. The time to remove each type of fin is recorded for each diver. So what do we think it is? A paired data or two sample? This is definitely paired t-procedures, because we have the same person that is doing both the control group and the treatment group, the old fin and the new fin. So the data come from two measurements of the same variable, time to remove the fin, for each diver. Question B, to study the health of aquatic life, scientists gathered a random sample of 60 white piranha fish from a tributary of the Amazon River during 1 year. The average length of these fish was compared to a random sample of 82 white piranha from the same tributary a decade ago. So we've got 2 different time periods, and we have 2 different sample sizes. That's a huge hint for us. These are going to be 2 sample T procedures. The data come from independent random samples of white piranha in 2 different years. Question C. Can a wetsuit deter shark attacks? A researcher has designed a new wetsuit with color variations that are suspected to deter shark attacks. To test this idea, she fills 2 identical drums with bait and covers one in the standard black neoprene wetsuit and the other in a new suit. Over a period of 1 week, she selects 16 2-hour time periods and randomly assigns 8 of them to the drum in the black wetsuit. The other 8 are assigned to the drum with the new suit. During each time period, the appropriate drum is submerged in waters that sharks frequent, and the number of times a shark bites the drum is recorded. 2 sample T procedures on this one. The data come from 2 groups in a randomized experiment, with each group consisting of 8 time periods. So that was a little tricky for us because we had the same sample size in both, in which a drum with a specific wetsuit, standard or new, was randomly assigned to be submerged. They came from 2 different groups, so that was our hint. Okay. We should by now be able to state appropriate hypotheses for a significance test about a difference between 2 means, determine whether the conditions are met for performing a test about a difference between 2 means, calculate the test statistic and p-value for a test about a difference between 2 means, perform a significance test about a difference between 2 means, perform a significance test about a mean difference, meaning that paired data that we've been looking at, and determine when it's appropriate to use paired T. That brings us to the end of the lesson for this section. If you have any questions, remember office hours or email. Hope everyone is good with this lesson, and we'll see you back for chapter 12.